Hello, my name is Nicolai Steinø. I'm an architect and an associate professor at Aalborg University, Denmark. I do research on parametric urban design, and today I will be talking about the CityVR project. I will not be showing any final material, but I will discuss work in progress and some of the issues that we're currently working on. Enjoy. We're 4 people on the project, and apart from myself, it's Claus Madsen, who is a computer vision engineer. It's Christian Mortensen, who's a research assistant, and it's Andre Lucaci, who's a mediology student. The aim of the CityVR project is to develop a workflow for the creation of VR environments for the evaluation of architectural interventions in urban space. The idea is to provide a tool for the evaluation of architectural projects in urban space before they're actually built by means of VR. This is useful for any collaborative design and planning processes which involve various stakeholders and interest groups, many of which would not be able to evaluate projects from architectural drawings and conventional media. It also makes it possible for groups of people who normally do not engage with such evaluations, such as children and school children and other people who would normally not entertain these kinds of processes. We work from a workflow including GIS, City Engine, Unreal Engine, and ultimately VR headsets or HMDs. In previous research, we've developed a method of importing GIS data from any location in Denmark, including terrain, and to automatically generate highly detailed 3D urban environments. This we can use in order to provide the context for such VR models in City Engine. In City Engine, we also develop the design proposals, the projects which are the subject of investigation. And once all of this is made in City Engine, we take the whole thing into Unreal Engine for lighting and navigation for VR purposes, and from there we move the model on to the actual VR headset. Now, as simple as this may sound, it does involve a number of challenges. Most importantly, the one of achieving a correct perception of scale in VR. Obviously, this is important if you want to evaluate how big or how small or how near or how far an architectural project is when experienced in urban space. Therefore, our research question is, how can we achieve a correct perception of scale in VR within the computational performance limits of the HMD? Because another challenge is that HMDs or VR headsets as they come these days have limited computational performance. In terms of this challenge, scale versus performance or scale perception versus performance, there's a number of ways to address it. You can make a very simple model like this one with a small amount of geometry, with few and simple textures. However, such a model does not give many clues as to the size of what we're actually looking at. What we then can do, of course, is to add realistic textures, such as this face break texture, as bricks are well known to most people, and therefore they are useful in evaluating the size of objects, at least close objects. On top of that, of course, we can add more architectural detail, windows, doors, and any other architectural feature. But one important aspect here actually is also the eye height. The images that I've just been showing here are viewed from 1 meter eye height, which would be that of a child. However, an adult would view the same scene more like this, which would give a different perception of scale. In other words, the eye height in which the model is experienced is also important in order to achieve a correct perception of scale. In terms of textures, realistic textures may well provide a sense of scale, but when applied to a too simple model with too little geometry, it may leave kind of unfinished or unconvincing impression with the viewer. Therefore, we've instead of using realistic textures such as brick and tiles and whatnot, we're currently contemplating and experimenting with the use of textures that would simulate an architectural scale model, such as styrofoam and corrugated cardboard and the like, because people will not expect an architectural scale model to have the same level of detail as a realistically rendered environment, and therefore the model or the overall impression may be more convincing to the eye, which is more tolerant when what is expected is something of a lesser detail. However, when it does come to realistic textures, another aspect is that it's quite important that these textures are scaled to their true scale. Obviously, bricks need to be the size of bricks in order to convey an idea of the size of the whole environment. However, when we set everything up in a CityEngine, which we can easily do and control the scale, and export it into Unreal Engine, we currently have quite some trouble getting the scaling right. And actually our computer vision guys are struggling quite a bit to develop or figure out a workflow that will control this smoothly and automatically. You may wonder then, of course, why even bother to take the step into a game engine, as CityEngine actually does have some VR functionality. This shows the ArcGIS 360 system, which is a series of 360-degree view domes that can be generated directly from within CityEngine and then displayed in a head-mounted display, a VR headset, or as in this case on your mobile phone. And it allows you to simply swap between different locations where you can view the model in VR from fixed vantage points. However, as soon as you take the same model into a game engine, it's not difficult to see the radical difference in render quality and the possibilities of lighting that a game engine offers, even in a quick work shot like this one out of Unreal. As mentioned, we also want to be able to toggle different scenarios once in the VR experience, where different aspects of the proposal can be altered, such as the volume or architectural styles and other aspects. And to this end, we use the scenarios functionality of CityEngine to develop different scenarios for the proposal. and then we transport that into the game engine. And that way we can from directly within the VR experience toggle different scenarios and evaluate the different scenarios against each other. Navigation is also an issue. There's basically two ways of navigating a VR space, as obviously you cannot move around in real physical space the way at the same distance as you would travel in an urban space in a VR model. And one is to simply float around in the style of a Harry Potter ghost, and the other is to beam your way about by means of a lightsaber in a more Star Trek beam me up Scotty fashion. In this example, which is actually a recording from directly within the VR headset, and as some of you may notice, we currently use the Esri template for importing City Engine models into Unreal. And here you see how the floating navigation works. You simply smoothly hover your way through space. The problem here, of course, is to control the eye height, as we want to have a fixed eye height above ground in order to give a realistic perception of scale. In this other example, the other technique is used. Again, we're in the Esri template, and once we beam ourselves into the model and get the lighting right, you can see how in this example, navigation happens by way of pointing and clicking, and then zack, you're zapped to the location that you're pointing at. This is actually not very good for scale perception, as you do not have a physical experience of how far you travel by this beaming technique. And it would require restrictions as to how far you can beam yourself forward in one click. On quite a different note, I just also want to show you some experiments we're doing with 360 photos in urban space. This shows a photo again on the phone. That's why the lines are so distorted, but it can obviously be experienced also in the headset. And this leads to my concluding remarks on our perspectives, because as soon as we got this whole workflow from GIS, City Engine, Unreal into the VR headset, what we want to do is to make a model from a real location in Aalborg and to add a demo architectural project to it with different scenarios. We also want to make a series of 360 photos from the same location. And both of this we do with the aim of making a comparative user test, comparing the real-world experience with the model experience. And all of this, of course, with the aim of figuring out how much level of detail, what type of textures, what type of navigation, etc., is better in terms of achieving a correct perception of scale in such a VR experience. And this, ladies and gentlemen, was what I wanted to share with you today. Thank you.